Today we're going to talk about migrating from a controller-based wireless LAN architecture to the cloud. It sounds a lot scarier than it is. We have an accompanying white paper which goes through the basic steps. It's really not that bad. There are just some things you need to consider, but Mojo Networks makes it actually pretty painless to perform this. So overall, we're going to talk about 8 different categories, or these aren't really steps. These are 8 different things to consider. One is, just the benefits of the cloud. So I'm assuming many people know the benefits of the cloud, or you wouldn't be here today. And then the rest of this is really more about implementation and things to really be concerned about. So Erica, I believe we have a poll question coming up.
Yes, we do. We're going to be running 2 quick polls today for everyone on the call. So just wanted to start out with polling whether or not your organization currently uses a WLAN controller. Simple yes or no. We just wanted to get a survey of what people are dealing with currently today. Okay.
Yeah, this helps me understand who the audience is and the level of engagement with controllers, because controllers have been there a long time. Cloud is the future of everything, including wireless networking, and so it's a reasonable assumption that people are looking at moving things to the cloud like most other applications are. Great,
thank you. And just to let everyone know, Robin, 85% of the attendees on today's call are still currently using the controller-based.
Awesome, great opportunity to hopefully allay some fears. So overall, we're going to talk about the benefits of the cloud. I'm not going to go through all these things. I'm going to talk about some important points. One of the important things about the cloud versus a controller architecture is that a cloud is really linearly scalable. Because there's massive resources in the cloud of compute and memory and communications, it's really can scale much larger than a step controller-based architecture. So with a controller, some of the challenges are you have to buy a controller of a certain size and you pay for that controller up front, even though you may not be using all of its capacity. And then when you max out the capacity of that controller, you have to buy another controller and more licensing. So it's just really this step function. You buy something, you max it out, you buy something else, you max it out, and you keep doing that. With the cloud, it's really very linear. You buy the number of APs you need, and the cloud manages those APs. So there's no, you're not buying more capacity than you need, and you add things as necessary. And cloud is essentially infinitely scalable. You can add more and more resources, add more and more access points as big as you want, because the cloud capacity is so massive. The other key thing is manageability. With the cloud, since there are the Mojo architectures that we have a lot of microservices in the cloud, and these microservices all communicate with each other via APIs. And there's a couple of real advantages of doing that. One is, well, you don't have to worry about interoperability with controller-based architectures and other appliances. So if you have a controller and if you have some management appliance and you have some guest appliance, you have to make sure those things all interoperate, and different versions of code work and different versions of code have bugs, and so you may have to get things just right to make them work. And that's a big challenge for an IT organization. It takes a lot of time to do that. With the cloud, a lot of that goes away because the cloud because all these microservices are talking via APIs, there's really little or no interoperability issues. And if there are any interoperability issues, it's dealt with by the cloud operations team. So your local IT staff doesn't have to worry about any of that stuff. So there's a huge benefit to managing things in the cloud and making sure all the pieces are in the cloud. Now, of course, not everything can be in the cloud. You don't necessarily want everything in the cloud. You may want some things locally, like you may want a syslog server locally. So there are ways to work around that. We actually have a new product called MultiService Platform, which can get syslog messages from the cloud to your local syslog server. I'll talk a little bit more about that later. And then the last thing I really want to talk about here is the economics of this. So with having all these resources in the cloud, you're really getting away of a lot of these separate appliances on the premise, and that can be can have massive savings We commissioned a report last year that showed that the cost of ownership, the total cost of ownership for a controller-based architecture versus a cloud-based architecture, is you can save up to 56%. So, you know, some budgets may not have a problem. You've got this invested already, so it's not a big deal. But that's a pretty huge difference. And with the other benefits here that I'm showing on this slide, there's a real compelling case of moving your Wi-Fi to the cloud. And I'm sorry, this presentation doesn't really flow. These are all just kind of point pieces, so there's no real flow. So I'm just going to talk to each one of these points. So one of the main concerns is, okay, I'm going to switch over to the cloud. That, you know, one of the reasons I'm doing that is because my APs are older generation. They're not quite doing what I want them to do, so I need new APs. So when I move to the cloud, what really matters? Okay, well, AP placement may or may not matter. What you need to determine is, well, if you're changing the physical AP, it's going to have different capabilities. So if you have a really old architecture that was, you know, BG only in 2.4 gigahertz, and now you're going to a 5 gigahertz AC Wave 2 device, well, you need to take account of that 5 gigahertz and what its coverage is and what your goals are. So you're going to have to, that's something you're going to have to look at very closely. So you're going to have much more capacity on this new AP. It's got bigger processor, more memory, can handle more users. So those things kind of make a difference. So there's two basic things you need to worry about. You need to look at the physical environment. So has your physical environment changed since you put your APs up last time? You know, tearing down walls or putting up filing cabinets or all of that stuff, moving cubes around or moving offices, all that can make a difference. You may need to update your cabling, because if you have a really old system, you may not have the most recent cable that supports the necessary PPOE, PPOE plus, you know, Cat 5, Cat 6 requirements. Then the other thing to look at as well, okay, these APs were placed and things have changed. Well, now I may want to have different coverage. I may want more coverage because I may want to take advantage of these higher data rates, because maybe when I planned my original AP placements, it was just for basic coverage at a very low data rate. Well, now I really, you know, my whole office is getting rid of Ethernet and everything's going to be wireless, and I want to have fast wireless connections. Well, I need more APs to be able to handle that because they need to be closer to the access point. So coverage makes a difference. The other thing to consider is, you know, now clients are becoming wireless only, and so you're going to have, and people have more wireless devices. You know, I have 3 or 4 wireless devices on me right now, so their client density per AP goes up. So you may need to consider how many APs, how many devices per AP. That makes a difference on where you put the APs and how many APs you need. In addition to that, it's not just the types of clients, but the applications that are being run on those clients. The applications now have changed considerably. You know, before on your phone, you could only make a phone call and then possibly some text. Well, now you can run high density HD video at amazing quality, which takes a fair amount of bandwidth. So if you're going to have that kind of environment where video is commonplace for lots of users, you need to make sure you have the right AP density for the applications. And then, like, same thing as kind of the client capability, you know, more clients are becoming more capable all the time. And so there's more clients per user, and they're all more capable, requiring more bandwidth. So these things, you may need to redesign your wireless net before that. What really doesn't matter, though, is your backend architecture. If you're controllerless, cloud-based, if you've got autonomous APs, that really doesn't matter on AP placement. That's all just kind of infrastructure. That all talks through the wired infrastructure and doesn't really matter about where you put the AP for that. And then lastly, and this is kind of a new thing, is that network design really doesn't matter. You know, I'll get to this in a second, but the way your VLANs are set up on your wired infrastructure used to make a difference, but now Mojo has come up with a new platform that can manage that and make it very easy for the transition from a controller-based, which really tunneled through a lot of this problem, to cloud. So let's talk a little bit more detail. With controller-based architectures, all the APs, or a lot of the APs, depending on the architecture, tunneled back to the controller. So you didn't have to worry about the VLANs on the local access switches. So it made your network design for VLANs actually pretty simple. Everything just got tunneled back to the controller. Before, with Mojo, everything was layer 2, and when the data came out of the AP, it got dumped onto the local infrastructure at its access switch, which means the access switch, if you had multiple VLANs on that AP, had to be able to handle those multiple VLANs. And that could be a challenge, because you may have to, before you had to redesign your wireless network, or sorry, your wired network to handle this much more robust wireless network. Well, now we realize that that's actually a challenge for some people, because nobody wants to redesign their network just for a new application or for changing things. It's just a lot of work, and if you don't have to do it, why do it? So Mojo's come out with a multi-service platform, which allows you to tunnel each one of the APs back to the multi-service platform and do all your VLAN switching and routing from the multi-services platform. This means you have a tunnel from the AP to the multi-service platform, and you don't have to change any of your VLAN infrastructure. So that just means that the data portion of the data portion of your clients is going back through the multi-service platform. All the other management and control functions and cognitive plane functions are still handled not through the multi-service platform. The multi-service platform is, like I said, relatively new, and it comes in 2 flavors. There's a medium and a high-end appliance, and really depends on where you are and what you need to make your transition simpler. Erica, time for another poll question.
Great, thank you. And for anyone who just joined, we ran a poll in the very beginning that just asked everyone who was attending whether or not they were still using a controller-based WLAN, and over 80% of the attendees today are using that. So now we'd like to ask, what's your biggest concern regarding migration to cloud-managed Wi-Fi from the controller? We give 3 options here. There might be some more, but just wanted to quickly gather some opinions from the audience.
Yeah, so we kind of put these together. There may be other concerns, and if there are other concerns, please send questions to us so we can address those. But the concerns we thought of off the top of our head is the downtime associated with migration, and we'll be covering that in just a bit. The acquired network architecture changes, and we think we just talked about that with the VLANs, and then the controller and security capabilities in the cloud. I think that's a pretty common concern, which we'll address shortly.
Great, thank you. I'm going to head and close the poll, and just to let everyone know, it's pretty much as before. About 83% of the attendees are concerned around the control and security aspects, whereas 17% are more concerned around network architecture changes. So downtime does not seem to be an issue with those who are attending today. Okay, great.
So just to address, unfortunately, I can't make this presentation dynamic to the questions. I wish I could. But to kind of address the downtime question, you can have cloud and controller coexistence. You can have APs of different vendors coexist in the same enterprise or environment. But what you really want to make sure you do is have RF separation between the 2 different types of AP systems. And this isn't just, this isn't just cloud and controller based. This is really any kind of controller, any kind of Wi-Fi to Wi-Fi transition. Wi-Fi interoperability, vendor interoperability between Wi-Fi. When you do roaming and things like that, the APs need to talk to each other, and different vendors really don't talk to each other. So to make it simple, you want to make sure you have a deployment where you're transitioning a region at a time where there's RF separation, so that the APs of one vendor don't see the APs of another vendor. And And that's really, you can break it down by, it's easy as, well, we're going to do this building, because buildings don't usually have a lot of RF overlap. Or you may be able to do different locations. Now, you can have RF overlap, and it will work. There's just a couple of downsides. Since the APs don't communicate with each other about the client for the roaming times will be longer. There will be no fast roaming. So if you're using 802.1x, you will have longer roam times. But there won't be roam time increase when you go between the two different vendors. So once you get on a vendors, a homogeneous vendors network, everything will be fine. It's just when you transition between the two, there will be a little bit of a challenge. And just to go back to that, if you have a large enterprise or a large deployment, you really do want to stage your rollout. And if you're unsure about the cloud, you probably want to trial it somewhere. You want to do a proof of concept to make sure you understand what's going on. So you want to deploy it one place. And so just be aware that there may be some overlap issues if you do that. So this kind of gets to some of the security question. A little bit, but not quite. I promise we'll address that. So this is really about authentication. So if you have a AAA server, a Radius server, it's really independent of the controller in the cloud. So we integrate with AAA servers, with Radius servers. If you want to use 802.1x for authentication, Mojo does it just like anybody else does. The difference is in the controller-based architecture, the controller acts as, it's called a NAS client. So the controller is actually doing the connection to the Radius server. In the cloud-based architecture, the AP is acting as the NAS client. So you need to make a change on your Radius server to allow all the APs on the management subnet to be able to talk to the Radius server. So a pretty simple change, not a lot of overhead, pretty basic. So the other thing that's concerned about the cloud, so a lot of people don't understand how cloud access points work, and we're not going to go into a lot of detail. We have a lot of this information on our website, but we're going to talk a little bit about it here. We've optimized the way APs work. In the controller-based architecture, the APs talk to the controller, and really, in some cases, it's called a split MAC architecture, where the AP did half of the work, and they're lightweight APs, and the controller did a lot of the other part of the work. And so every packet had to go through from the access point to the controller, and then back from the controller back to the access point, creating a lot of network overhead. And so that's because the controller managed all the client associations, it could help with roaming much easier. That was one of the advantages of the controller-based architecture. We have a distributed control plane, which means that the APs talk to each other. We don't have a controller. Even with a MultiServices platform, the control data does not go back to the MultiServices platform. Only the data packets go to the MultiServices platform. The control information, roaming information, client state information, is shared between APs. So when a client associates, we'll get to this. So just a little bit more about the control plane. So Mojo has a architecture of allowing APs to talk to each other that are nearby. So when a client roams from one AP to another AP, that client information gets shared to neighboring APs. So here's an example. A client is connecting to an access point. That access point then sends a broadcast packet on to all its layer 2 neighbors. The layer 2 neighbors will gather that and store that information about that client on their AP. So when the client roams from one AP to another, all the client information is available to that new AP. So it cuts down roam time. And that includes the fast roaming pre-shared master key ID. So you can do fast roaming even in this distributed fashion. So the way it works is we have a inter-AP communication protocol, which does smart exchange. So when an AP is connected and a client connects to the AP, it actually figures out who its neighbors are. So in this case, AP1, the AP we're looking at, it can see its RF neighbors are APs 2, 7, and 8. So it's going to send a broadcast out to those APs about its client information and about its RF state information. And APs 2, 7, and 8 are actually going to pay attention to it. The rest of the APs are going to discard it because they're not the RF neighbors. They know who their neighbors are. Similarly, if we look at AP7 has 8 neighbors. So it's really a smart information exchange that keeps the amount of data on each AP small. So instead of having all the stuff on one controller, every AP is client information on one controller, we have all the client information on the neighboring RF APs, making this tables much smaller, but maintaining the fast roaming capabilities and the client state information. So moving on. So, you know, one of the concerns about cloud APs is security. So one of the things about security is, okay, now things are going off of my network, freaking me out. I don't want all my data to go off my network. I don't want it to be somewhere else. Well, with Mojo, none of the data leaves the network. It's all on your network. The data packets from the clients never leave your network. The only thing that leaves the network are management plane information and cognition plane information. So management plane information is updates and information, you know, state information about the AP, and state information about the clients, but no client data. You know, MAC addresses and things like that will get shared, but no actual data packets from the clients go to the cloud. Similarly, the cognition plane allows the Mojo access points, or the Mojo infrastructure, to do some really cool stuff. With the cognition plane and the cloud that Mojo has, we can do things that make the whole system much more intelligent, and you need much less resources in IT to manage it. For example, an AP now, the Mojo AP can do root cause analysis. So if there's a connection failure, the AP will do the root cause analysis and share that information with the management, with the Mojo cloud. So you can go to Mojo cloud and say, somebody calls you and said, hey, I couldn't connect to the network. You can go to the Mojo cloud and it will say, oh, well, you're using the wrong pre-shared key. The AP does the analysis and the cloud presents that data. Similarly, some of the other cool things about Mojo Aware, which is our implementation of the cognition plane or the cognitive Wi-Fi, is we do auto packet capture. So if there's a connection failure, the AP is capturing all that packet. So you never miss a packet. If you need to do a deep packet inspection of what's going on, you want to see the packet trace, we gather that and we post it into the management platform. So you can go and gather and look at it any time. So if somebody had a problem yesterday connecting, that trace will be in the cloud. Now you don't need that because it's already, the AP is already told you what the problem is, but if you want to go look at the trace for that, it's in the cloud and you can go and download it to Mojo Packets or to Wireshark to go look at the packets independently. The other thing that's really cool is instead of doing, typically for management platforms, the wireless management platforms have thresholds of, what is good and bad, how many retry, what's the retry rate, what's good and bad. A lot of that is kind of superfluous. You don't really care about what's good, you care about what's bad. As IT staffs get smaller and more stuff to do, you don't really care. You can go and monitor your network, but do you really care that, yesterday you had 500 people on your network and today you have 501 people on your network? No, what you really care about is yesterday somebody had a problem and today 2 people had a problem, and I've got to figure out what's going on. And so the way we've approached this with Mojo Aware is, let's, instead of taking all these static thresholds, which lead to a lot of false positives, false negatives, let's put baselines in, anomalies. So we'll baseline your network and say, this is what's normal for your network. And hey, something happened here which is outside your normal baseline. You should probably go look at that. So it's a much more intelligent approach to network management and network monitoring. And then, so I get excited about Aware, so I apologize, I'm rambling on about this. And then the last really cool thing about Mojo Aware is APs with a third radio, like the C130 and the C110, are able to do a client connectivity test. That means they can use the third radio as a client to connect to another AP. So if somebody reports having a problem on an AP, you can go to a neighboring AP, connect to that AP with a third radio as a client to make sure that that client can connect to that. Saves you time from sending somebody out with a client to connect to that AP to see what's going on. The AP can do it automatically. It's pretty phenomenal stuff. I'm sorry, just to go back to that. So that is the kind of information, a lot of the stuff happens on the AP, and the basic cognition plane information and just the management information gets shared to the cloud. Again, just want to make this point very clear. All the control data between the APs and the data, the client data stays on your local network. So there's no risk of being breached, the client data being hacked and seeing what's going on. The other thing to make note of when you talk between the local network and the cloud is to be able to talk to the cloud, you do have to have some open ports to the network. So we use some pretty common ports and a couple of less common ports. So we use TCP port 80 and 443 for a lot of the AP management. And then we also use a special port, UDP 3851, which is unique to us, for connecting APs to the cloud. Recently, we've just come out with a proxy, so we can get around opening a firewall port for UDP port 3851. We can use a proxy, and the proxy will talk over TCP ports 80 and 443. So you no longer need to open your firewall specifically for Mojo. And then UDP port 3852 is really used for the cloud integration point that's connecting the cloud to local services, local on-premise services like a network management system or like syslog or things like that. If you use only Mojo for a WIPS solution, we can send wireless LAN controller client information to the cloud so you can make your WIPS that much more effective. The important thing here is that the access points really use a very small amount of bandwidth. So the amount of bandwidth you use per AP is about 1.5 kilobits, so pretty tiny. And the other important thing is all communications between your local network and the Mojo cloud is secured. It's encrypted. It's an encrypted. So it's, we Mojo as a company started as a security company. We really invented WIPS, and we've kept going with that. So everything we do has an eye towards security. So I'll talk a little bit more about that in a second. So this just kind of reiterate what I just talked about. So we now have a cloud integration point. It is based on the access point, the C120. You turn a C120 into a cloud integration point. So it's just another AP in a special mode on your local network. That creates an open VPN tunnel to the Mojo cloud. So you can actually go through the firewall. So all your local APs that are using UDP 3851, I'm sorry, wrong thing here. This is for connecting the cloud to your local devices. So if you have wireless LAN controllers or enterprise management, like syslog, cloud integration point will pass the information from the local network to the cloud, local services to the cloud, and from the cloud to the local services. So you can have your syslog server on premise and get syslog data from the Mojo cloud. One of the main concerns I think a lot of people have about having your network in the cloud, so to speak, is what happens if my network connection to the cloud, what if my WAN connection goes down? So fair concern. Because we have such a distributed architecture, because we only send management and cognition plane data to the cloud, all the APs are completely functional should you lose your WAN connection. They work perfectly. They do the firewalls. They do all the security stuff. You only lose a couple of pieces of information. You may lose some client state information because it can't post to the cloud. But almost everything else, the AP is completely functional. So if your WAN connection goes down, your users will not be impacted by your wireless network. So really nothing to be concerned about there again. And even when the WAN connection goes down, the AP is gathering information and storing it locally until the WAN connection can come back up, and then it will post that information to the cloud to catch up. And not all information, but 90% of the information. So that was everything. So the couple notes I wanted to make about, oops, sorry. A couple things I want to talk about, because Mojo Network is essentially started as a security company, we've done a lot of things to make our whole implementation secure. One of the most recent things, which is pretty exciting, is that because we're a cloud company and we have our services, our microservices hosted in the cloud and somebody else's cloud service, there's really a shared responsibility model between the cloud service provider and the applications being run in the cloud. So in this case, the application being run in the cloud is Mojo Networks. And the cloud hosting service we use today is AWS. So AWS does a great job about securing their infrastructure. But because it's a shared responsibility model, they leave it up to us to make sure that our applications are secure. And so when you look at other cloud companies, they'll say that they have SSAE 16 SOC 2 compliance, so they have certification. What they all mean is that their hosting service is SOC 2 compliant or certified. What they haven't done is made sure that their applications, their implementation on the cloud is SOC 2 certified. So Mojo Networks is the only Wi-Fi vendor today that has gone and completed a SOC 2 audit to validate that our processes are compliant with SOC 2 certification. So brand new, again, this is showing that we take security extremely seriously. And so we've gone the extra step to show that all of our processes and applications implementations are secured and been audited by an outside firm so we can get this SOC 2 certification.